Great. And hi, Daniel.
Hey, sorry. I thought I had a conflict, but apparently not. That conflict may open up the WebEx soon, so I may have to drop. But glad to be here.
So, guys, I didn't have much. I didn't create an agenda for today, but I was going to make a suggestion. And the first part of that is I'm going to put my hands up and say I've been very poor with my plan because I had said that I was going to create a sort of a roadmap. But I think one of the things that happened is I started to do it yesterday, and I realized there's a lot I didn't know. So I sort of wonder whether maybe everyone who's working on different elements could help me with some bullet points. I don't know whether maybe Ryan could shoot me some sort of roadmap points for the dashboard, and Adrian could shoot me some roadmap bullet points for the infrastructure for the containers. And if John, if you had any ideas, I mean, I more or less know, I think, about firmware, but if you had anything, I can make a start and show it to you, John. But at least those two other points would help me a lot if I could ask for that, please. And then by the next meeting, I'll have something.
Yeah, I can send you over some stuff for the dashboard. I mean, I've been wanting to get that up on the GitHub projects also, so it's on my list of things to try and think about what we need to finish out everything the dashboard should have.
Super high level, just because I just want to sort of have just a few items on each for the overall roadmap. I'm sure we can get fancy later and tie in all the projects as well. So that was for the plan. If we want to just go around, I'm just going to quickly start with the sensors and just say that the first 100 sensors are made. Right now, I have got someone testing them. So I'm just sort of loading firmware onto each one, and then some guys making sure that it does all the right things, and we're having no failures at the moment. And from those, we have 20 that are going to Vaclav for the Nepal installation. And then the rest at the moment will all be going to Puerto Rico. And then we have a new batch being made in China as we speak, although it's Chinese New Year at the moment. So that's going to be another two weeks or something. Plus, a lot of areas in China are in lockdown. So that's also going to affect us. But anyway,
the first 100, the PCBs were cut in China, but then assembled in Mexico.
Yeah, exactly. And actually, it's taken about 2 months longer than it should have because the shop that I went to here was not very good at sort of low volume production. So they take ages to ramp up. I think that was the problem.
Okay. But it's good to have the 100 devices. And at least the first few that we got, there was a whole bunch of rework.
Yeah. So that was also because they didn't have the right feed. So each of the little components that goes into the assembly job requires different types of these feeders that sort of like take the reel and sort of spit them out. And they didn't have the feeder for the tiny ones that we did. So they were just using something that was not appropriate. That's all been fixed. Anyway, from now on, it's all going to be done in China. And I'm very grateful for Arrow's help, which is a sort of introduction, I think, through Daniel, because Arrow have allowed us to retain the pricing on the ADXLs. So if you can imagine the ADXLs, if you buy one or two today, they cost $45. But we're able to get them for about $29 each or $28 each. So it's an enormous difference, and it allows us to get the pricing that makes them affordable. So that's sensors. Do you have anything to say about firmware, John?
So not much recent. The firmware pretty solid. What I should do is publish the 1.3 firmware. I sort of got as far as I was going to go during the Christmas break. There was, and I see that James is joining. That's wonderful. And the firmware talks to the provisioning app, and that's pretty straightforward. The only thing that I've really outstanding on my list has been just the algorithm for the LTA, and it's just sitting down, maybe sitting with Gareth and working through the math of Vaclav. But that's the only thing that's open on my top. Oh, so I did play with a version that would talk to local host, something on my local LAN, and for some reason, I think I was having firmware firewall problems on my laptop. the IBM firewalls locked down, and I could not figure out why it was preventing MQTT traffic. Because you had asked, I think in a ticket, you wanted a version of the firmware that would only talk to local network. Matter of fact, it was like what I ultimately got it down to was a 1-line change. So not a lot of difference in the firmware. So I was, well, you still talk to the cloud, and then the cloud responded with just a 129, 168 address, and it tried to open a connection and yelled at me about some SSL thing. Anyway, so if we needed to go talk to a local network MQTT broker, I was pretty close with that. But the hope was that I was leading towards, once Adrian and I figure out how to have the MQTT broker somewhere running in a cluster, if we needed to, we could just swap in continue to use the device management endpoints to control where we want the MQTT data to go to. So that was, sort of the whole point of being able to have this device orchestration technique, and I'm pretty close, I think, for that.
Great. Oh, I would mention, John, I don't know if you received yours, but I got my my board with the LTE, the 4G. Don't know if you got yours, but I actually put it on a breadboard last week and linked it up to an ADXL and just ran the code, and it works. It just works. So I think I had to mess around with the SPI address. I had to use a different SPI address. But basically, what that means more or less is that the firmware should be more or less the same. We just obviously we want to have the STA LTA in place first to minimize bandwidth. But that was really exciting for me, knowing that it was. I used a hologram. I'm sure it could be the Twilio one, but I used hologram in there.
Yeah, very cool. That's excellent. That's cool. I think mine set the ship sort of towards the end of February, 2 weeks from now.
Yeah. So the great news is it's more or less plug and play with our firmware.
Good.
Okay. Hi, James.
Hello, everyone.
Hello. Good to see you again. So what should we talk about next? Ryan, do you want to say anything?
Sure. Yeah, I can just update where we are on the dashboard. So it's been more of working on what we discussed 2 weeks ago. We're finalizing the onboarding process, the API now. You can call the backend API. It will create a account for you if you don't already have one, and it deals more with the user IDs coming out of App ID rather than email addresses. So gives us a little bit more flexibility for users to be able to change email addresses, and also makes it a little more secure that we're not passing around identification like that. And then Adrian has been working on collecting it all into a container to be able to be deployed on IBM Cloud Kubernetes. He can get more into exactly all the details of that and whatnot. And then Johnny was working on making the front end responsive, at least the events page, because we did a lot of custom stuff on the events page. So we just needed to look good on mobile, because I realized that people's first interaction, although the dashboard is primarily going to be a desktop experience, people's first interaction with it is most likely going to be on mobile, because they're going to hit a link in that onboarding provisioning app that's going to take them to complete their account on the dashboard. And most likely people are going to do that just from their phone rather than fire up their desktop computer or laptop or whatnot. So we need to make at least the entry points into the dashboard look really good on a phone. So that's all kind of part of one experience. So yeah, the two major things that need to be done to finish out that onboarding process are just create the part where you can finalize your account details, which I'll work on, and then it's the provisioning app itself just needs to be needs to get the flow finalized. And I see James.
Yeah, so now we've got James. We've got James here. We should talk to him about some of the changes and ideas that we've had. The the reason we've made a lot of changes, James, to the sort of the process is we're trying to reduce the amount of GDPR private information, both that's stored in the device management with the data, the earthquake data. And so that way, the only place we know where a person's name is and their email will be inside of an application ID management service that IBM's got in IBM Cloud. It's, OAuth, et cetera, et cetera. So it's called App ID. And within App ID, you create a user account, and it contains a whole variety of attributes, one of which is this unique identifier. So we are only going to use the UUID under the covers to associate the sensor with, in the dashboard, it'll look like John Wallachy at Gmail sensor, but in fact, with the data, you just see the UUID. And so we'll have in our databases, if you want to find, say I've got a network and I'm the administrator, I've got 10 devices or 50 devices, you might say, show me all the devices owned by this, whatever, John Wallachy, but then we're going to go look up what the UUID is and then query the database to actually just get by UUID. And that way we've disassociated the person and the email from the sensor and the data. And we think that's going to be more secure so that scientists can pass the data around without leaking private information. But that requires changes to the provisioning app. And so Ryan and I and others, Kristen, we've built a sort of a flow to help. So you still need to, the whole point of the provisioning app is to send smart config from the phone to the board to the cloud. But we're also going to use this to create your account. And so, Ryan, you want to talk through that process?
Yeah. So so basically, what happens right now, and it's something I want to get for the web developers out there, their opinion on, because we might have made it, or I might have made it a little too complicated. But it depends on where we go with it. But right now, the process is it gets to if you're in the provisioning app, you should just be able to put an email in, no other personal information. And when that email gets sent to our dashboard backend, it will reply whether they are a user or not. If they are a user, it'll just add their sensor to their account. If they're not a user, it'll create an account and app ID and then return a user ID. And then the last portion of the provisioning app will be a button that basically says just complete your account registration, which will, when they click on it, it'll take them to the dashboard and they'll create a password for themselves, put in any other registration information, and then that'll actually finalize their account. Now, the way that the link is generated, which I was just working on over the last week, is it takes the user ID and it stores it in a JSON web token, which is then planted in in a query string in the link that links the provisioning app with the dashboard. Now, the reason it needs to be in a token, I'm not exactly sure, because it really doesn't do much. Tokens are not for keeping secrets. Anyone can plug that token into a something that decodes JWTs and be able to get the user ID. But it at least confirms it, it'll sign it. So it at least confirms that the link originally came from our dashboard backend. Now, I don't know if that's, the problem with this is adding it to a JWT, and this is just sort of a technical consideration, right? But adding it to a JWT means that they also need a secret to go along with the JWT. So it's just one more thing to have to set up when you actually want to do development. So I'm wondering now, after I've already completed this portion, if we should just have the query string just have the user ID in it. And if anyone can think of any reason that would pose a security concern, or why, or if potentially people could predict what the link, if you know what a user ID looks like, potentially you could just create an account in App ID using a link. I don't know. I sort of have to think about the so much that usually with web development is goes into like trying to secure all this stuff and trying to make sure that no personal identifier. But we're really not dealing with a lot of real protected information in this process. So I don't know if we needed to have the same security that like Bank of America has, but but it's a consideration. Right now, the link contains a token, which will require a little bit of maintenance, but in the future, maybe we'll just trade that token out for something a little more straightforward. But anyway, once they get to the dashboard, they complete their process and they now have a dashboard account.
But so if I get this right, because I'm not sure I'm completely following, you were saying that to get some kind of data, you would put a JWT inside of as a query string inside of the URL. Is that correct?
That's the link. It already is in there. It's the link that sends it from the provisioning app to the dashboard, which is something we provide. But the way that it conveys the information from the provisioning app to the dashboard is through a token.
Right. Now you're saying that for that token, we'd need a secret, which is another thing to consider, which is annoying, perhaps.
Yeah.
So that you should just include, instead of using a JWT, you would use just an UUID, right?
Just the UUID from App ID, and just plug that in as a query string.
Yeah.
And if that poses, any sort of risk we can think of.
So the link itself enables you to create an account.
That's the trouble, is that the link, the link itself, if you have that link, you will be able to finalize someone's account, because that link is basically the sole measure that gets you into the finalized account processing. But I don't think the link will contain a code in it, and I don't think that people are going to, the only place where the link lives is in the provisioning app. It's not sent to you via email or anything like that. So the only people that are going to get access to it are people that have access to the app running on their own phone.
Yeah.
So it's not really, the only consideration, I guess, would be if people potentially could build that link, but that's not, they would need to know the user ID. So I'm sort of convincing myself right now just to take the token out and just replace it with just a query string with the user ID in it.
Yeah, I have two issues with that potentially could crop up. One is if in any way, shape, or form the database ever gets accessed, read from, then they have all the user IDs, which means they could, for any user which is not yet signed up, they could. Well, we obviously have bigger issues in our heads, but
yeah. I mean, if someone gets access to the entire user database, then then that's sort of worst case scenario anyway.
Yeah, but I'll ask that question to my friend who happens to do cybersecurity. But the second issue that I was thinking of, imagine if you're being a big dum-dum and you're in a cafe on a public Wi-Fi. Man-in-middle attacks are a real thing, and if you are on HTTPS, if you put it in the body of the request, then it's fine because then it's encoded. But the URL is never encoded, even with HTTPS, if I recall correctly. So if you put the token or the UID inside of the URL, even with HTTPS, man-in-the-middle attacks could intercept that UID.
But the token's not solving that problem because you can still read all the information from a token.
Yeah, but so what? I know that, but what I would do is perhaps instead of putting it in the, I don't know, well, no, we can't do that, right? I was gonna suggest that we put it in the body, but you're gonna send it to the browser, right?
Well, here's the thing that sort of mitigates that, though, is that it's a one-time use thing anyway. Once you create your account, we're going to have a check on the back end that basically says you can't create your account again. You can't use that link twice to be able to change account information or anything like that. So someone would have to be in the exact right position to execute a man-in-the-middle attack right on Wi-Fi and also be, intercept it and use that token or ID before the intended user is going to use it, which means that it's such a specific scenario that, again, like if we were creating a website for a bank, I would say that we could think about that. But I think probably the user ID is good enough.
But
But
what's the worst case scenario? Sorry, Ryan. What's the worst case scenario that someone creates an additional OpenEEW account?
If someone were to get a hold of the link itself, then potentially they could create the link in their name with their own password and get access to all the sensor data for that account.
Okay.
So that was the original, but there would have to be a lot of things that happen for that to be a scenario, right? That link is you can only use that link once. So they would have to get that link. They would have to get that link essentially before the intended user ends up using it. Because once the password is created and once the account is finalized, there's really nothing you can do. It's just a username and a password that gets you credentials to the site, and that's it.
Yeah, but say, for example, the man in the middle user, I may just be overthinking this, but I'm super paranoid about these things, so I'd like to entertain every single thing. And that is, imagine if the man in the middle attacker is actually aware of OpenEEW and has automated the process of registering a UID, which means that it's going to be automatically faster than any human being trying to register the code legitimately. Maybe I'm just overthinking. Imagine.
Yeah, so I'm trying to think like what the.
It definitely smells a bit to me to use the user ID. A couple of thoughts are that we could use a separate ID that is actually wiped once it gets used. There's no reason we couldn't generate a separate UUID that's used specifically for this purpose. The other thing we could think about is instead of linking directly from the app, we could do like an email verification step where it's like, send me an email, and that email will have like a magic sign-in link in it. And then the app doesn't have to worry about like sending credentials over to the web, which feels a bit odd to me.
So the email is where we started with, but then we realized that it's a much more likely scenario for someone to accidentally put the wrong email in, and then an email is sent with the sole account creation details to someone that we don't know.
So that's want to verify their email. We don't want people's having accounts that have emails that they can't access, right? There's an important security verification step where it's like you have access to the email that you told us that you have.
Yeah, but we move that now to basically just happening as you do the account registration. App ID just sends out a verification email, which you have to verify before you actually use the dashboard. But we took it out of the part where the sole link that allows you to create your password is sent in an email, just because if you put in the wrong email, someone gets the ability to create a password on your account.
What if we added an additional step in the way that first we have you verify your account, and using that, because if I just add an email and send a click, oh yeah, I have to verify it, any third-party person, which is not me, could click verify and then do their funny hacker business. But what we could do, instead of just having a button to verify, we could have a code that you need to enter into the dashboard or into the app that actually verifies that you are the person that
we thought about that verify. Too with a PIN number. So that was what John and I were talking about on Slack probably about a week and a half ago, was that we would add like a PIN number to it, but then we thought that was kind of too many steps. I think what James just said is probably eventually what we'll change it to. I think we're fine for now with what we have, and we don't have to like get into the details of security like too much on it anymore in the general meeting here. But like, I think what James just said is just creating a different ID, using the user ID. While maybe it's fine, it seems fine, it just like from a web development standpoint, it just seems a little sketchy perhaps. But having just a one-time use ID, I think, solves pretty much all our problems. And we can just store that on the profile inside App ID and then just get rid of it once their account is actually created.
Yeah, we're not a bank. We don't really need to overthink it.
Yeah, exactly. All right. Sorry to take up 12 minutes with esoteric security concerns for the dashboard, but I think that solves that.
Okay. And Adrian, do you want to say anything about the work you've been doing in the last few days?
Yeah. I mean, there's been a lot of stuff. So I guess in a nutshell, you guys saw my post where I added a couple GitHub actions to the dashboard, right? So whenever anyone opens a pull request, the action kicks off that does some linting checks. And when a pull request is merged, there's a couple more actions that get kicked off. So we start by building the Docker container. So I fixed the Docker container, so now it works. And then we push that up to container registry. And this whole time we've had a call for code Kubernetes cluster where the detection engine lives right now. So we're able to actually deploy the dashboard to the same cluster. So they're living together, although they're not talking to each other. So that works. Let's see what else. And then there's some miscellaneous things like Git hooks that I added and what have you. And going forward, I talked to John before we came into the meeting, and I'm going to take some of the work that he's done, take his YAML for deploying his part of the project and try to get it on the same cluster. But again, this is, there's, as far as I know, there's no real like end-to-end test to make sure that all the pieces are talking to each other yet. So that's what I've been working on.
So when you said John stuff, do you mean the Node-RED flow?
Right. So right now the Node-RED flow does device orchestration. It doesn't know anything about a network. We could add capabilities. Well, I don't want to overthink that. How do we do device orchestration across multiple networks? But right now we could have bespoke firmware for Puerto Rico. I was trying not to do that. I was hoping we would have one firmware for all of the devices and all of the networks, and then we could decide in the cloud what sensors belong to what networks.
Yeah, I thought you had done something to that effect.
That's how it works. That's how it works today. But it uses a central MQTT broker.
Of course,
If we wanted to, we could, right? You could query the database, figure out which MQTT broker is appropriate for that sensor, and then respond. It's sort of how it works, right? The sensor asks the cloud, where should I send my data? And it responds with, oh, here's the URL of the MQTT broker. So we could add steps in the cloud to figure out we know your sensor. Now, which network do you belong to? Oh, let's go look up which MQTT broker is appropriate for that one. So we could have a centralized device orchestration database service that figures out where to send the data to,
based on location.
Based on what the user, right? The user in the dashboard tells us which network he belongs to, right? That'll be something, Ryan, that you will add when we get to the device, the device page. The sort of the administrator or the user, okay, here's my sensor, it belongs to Puerto Rico, or here's my sensor, it belongs to Nepal, and in that way, you the admin decide what network it belongs to.
Yeah.
And at that point, then I could say, oh, it belongs. Once I know you're in the Puerto Rico network, send your MQTT data over there, wherever that is.
Just taking Puerto Rico as an example, given that in the near future we're going to be shipping devices there, the people installing it will not be the same admin. Like, for example, we would be the admins of the Puerto Rico network, so we would be the ones having to assign those sensors in the dashboard. So we could do that, right? We could add ourselves as users to those.
Yeah, that'll be a role that we'll have.
Okay.
So the dashboard right now is set up, or we have designs to set up the ability to add accounts just from a administration access page. But we should probably also think about building in some sort of user interface to be able to add sensors quickly. There might be a use case where, Andy, you need to add 50 sensors to a certain network, right?
Yeah, absolutely.
You don't have to the onboarding process requires you to have a separate account, or no, when you would all put those on, but you would have to go through the onboarding process for each one of those right now, as opposed to just being able to add them quickly.
That's a really good idea, Ryan. That's really good. I can foresee that being really useful.
I get all worried because then the whole point was to capture the location when you provision a device. We want to know where it is.
Yeah. Oh yeah, because and that's relying on. So if Andy, you did it in your office, it would basically just say that all those sensors are in Mexico City.
Right.
Yeah.
Yeah, no, that's a good point. Yeah. Whilst you could manually add them in, someone is still physically going to be going to each of the sites and connecting them. So I guess.
Yeah, but but no one. We were quite purposeful in only the provisioning app. When you turn it on, you say, "Here's a new sensor." That's the point where we capture the geolocation of the smartphone, and that's what gets written to the database.
Yeah.
Yeah, exactly. So I was thinking when Ryan said what he said, that I was imagining that we would provision them as in giving them users, but not necessarily giving them Wi-Fi and location, that they would still need to go through that process. But I guess it could be done.
Okay. Well,
in reverse.
You're building a whole new path. We have to think it through.
Yeah. Well, I mean, probably with Puerto Rico, at least, I think that we'll start to understand the problems that need to be solved with it anyway. I mean, there might be a case where everybody is just provisioning a sensor individually. But yeah, I mean, we could figure it out kind of as we go.
But here's one thing I do know, Ryan, is that we're going to be sending them and then we will never see them again. You know, like when they go to Puerto Rico, they are not in our hands anymore. And so, and the people they're going to are not, you know, they're sort of, they're not signed up in the way we are or citizen scientists are. They're sort of doing it dutifully because they've been asked to. So we have to make it so that, you know, they do the minimum number of steps and then we have to do whatever we need to do to onboard the devices ourselves later.
Well, I do know that
it's already there. I mean,
the flow we're using now, I mean, I think it's hopefully when this is done, it'll be very easy to add a sensor from an individual, right? Because it's really no different than setting up a Apple TV or a Sonos speaker or something like that. It's just you have an app, and then that app automatically is collecting the information it needs, and then it gets you an account and it throws you into the dashboard, and that's all you. So there might be another use case we can think about later on where, okay, so what if an administrator on the top needs to provision a bunch of apps and a bunch of sensors rather, but you know, I guess we can get to that when we you know, after we're done with this, but I do think that it's what we have now. I think will be really easy for an individual to add a sensor quickly.
On a slightly different note, I think what would be a very important functionality would be able to push a firmware from the dashboard or from some kind of user account to the sensor. I think that's maybe not for like citizen scientists and people like that, but for network managers, I think we'll have multiple versions of firmware that will operate in different locations, because some people may want to collect all the data, some people may want to do the triggering this way or that way, and being able to push different firmwares on different sensors, I think it's quite important.
We do have a firmware check topic, so you can from the dashboard send a command down to have the board check this. It basically asks, do I have the latest firmware? And then it responds like, here's the version of the firmware and here's where to find the new one is if you don't have it. And so that step, the over-the-air firmware upgrade, does work.
Mm-hmm. When you say dashboard, you mean the Node-RED dashboard, right? Not the other dashboard.
Well, currently it's working in the Node-RED dashboard, but Kristen has ideas on how to bring that into the official dashboard.
Yeah, she's working on the sensors page right now, and you know, hopefully we're really using the Node-RED dashboard as template for it, where most of the stuff you should be able to do that you could do in Node-RED, you should be able to do eventually, at least in the web-based dashboard.
I really that's really exciting for me, and I spent a little while the other day looking at the particle dashboard, just because I have some particle devices in the field, and as John mentioned once, that was a team of 100 people over 5 years, so we're not going to come close. But there is a way they structure things, which I think is really good. I'll try and share something in Slack, some screenshots, but there is something really nice, and there's some sort of key stats which are really useful. So like they tell you what is the current firmware version of your device. They tell you a little bit about its uptime, and so some, why
we have that. Both of those we have, yeah.
We can get all of that information. It's just work on our side, but I mean, it's all there.
It's in actually, I write it to a cloud database.
Yeah, it's already in the, all we need to do is build a user interface for it and bring it down. Yeah. All that stuff is the, is there. And is the functionality, I mean, John, just to be able to update the firmware, that's something that we can, like, that's an endpoint that we could be able basically just call on our dashboard backend, right? And have it update.
Well, yes. You issue an MQTT command to the board, and the board subscribes to a bunch of commands. And so it subscribes to a firmware check command. So you could ask it to do a firmware check for itself.
Oh, okay.
And then it kicks off a function that says, I need to do a firmware check. Here's the version of the firmware I have. What should I do?
Oh, okay.
And then the cloud side then responds. It listens to the check-in, and then it responds back down to the board saying, here's the version we want you to have, and if you don't have it, go and download the bin from wherever, and it gives you a URL.
Okay.
And then the board says, okay, I don't have that version. Let me go download the binary and then reboot itself. And basically it reboots to the new firmware.
Yeah. Okay, yeah. So even adding the functionality of the firmware check and everything, I mean, we're close to that on the dashboard too.
Yeah.
Just for fun, I'm just going to share my screen. Let me do this. Yeah. So I'm not trying to deviate what we're already doing, but I just got excited when I looked at their website. They've updated their website recently. This is Particle, and so what they've done is, there's nothing new here, but it's just very clear, the way they do things. And what's amazing, I think, that we've already accomplished, more or less, is that we can do remote updates. I mean, that's one of Particle's biggest selling points, and we've more or less done that. So I think that's pretty fantastic. And then here, how they talk about how much data has been used. This is because they're so focused on cellular, which one day we might need to look at, but there's just some really basic sort of bar graphs relating to the last week of usage of the device or whatever. I'm not saying we need to go into much of this detail, but I like the way that they've organized their sort of sensor information on their dashboard, because they have lots of other things going on their dashboard. So,
yeah, what I imagine will happen with our dashboard is that when this dashboard is functional and you can at least sign into it, there's a minimum viable product, and you can get an account, onboard a sensor, go into the dashboard, you can see the sensors, that you own and others in the network and whatnot. When you start actually being able to use the dashboard, we're just going to have a flood of different things from everybody that says, I would find this useful and I would find that useful.
Right.
And then we'll try and organize it and see what we have for version 2.0. But we're at the point right now, I think, where we're just kind of guessing at what might be useful out of the dashboard. We know that all the Node-RED stuff is useful, but what on top of that, I think will come when we actually get a functioning dashboard and people start using it on a daily basis.
Got it. Vaclav, do you want to say anything about the work you've been doing?
Yeah, sure. So I've been working on that real-time processing of the data, and I got some first full fully working version. If I can share my screen too, I'll show you how it looks. Can you see my screen?
Yeah.
Yes.
So, so pretty much what I'm working on is that this is, it's like that real-time algorithm for processing of all the data. So this is the Mexican network. The white triangles are the stations. And then we have an earthquake. There's like plenty of earthquakes here. So each slide is one earthquake. And it's like that output of the real-time algorithm for the processing. And there's always a white star and a red star. The white star is the epicenter of the earthquake as it was analyzed by the Mexican network, the SSN network. And the red star, which is right behind the white one in this case, is the location that was estimated from my real-time algorithm.
Oh, that's incredible! I didn't realize that the white star was the catalog, right?
Yeah. So actually,
Wow, okay.
like in this case, it fits pretty well. So the color map behind is the probability of the earthquake location. So and the red star is the where the probability is the highest. So in here, because the geometry of the network is like more or less in the northwest southeast direction, so we have the error, the red patch, which is elongated in the northeast southwest. So because we don't have that much data in that direction, and the Mexico City stations didn't record this particular earthquake, and the red stations here, or the red triangles, are the stations that triggered during this magnitude 5.0 earthquake. And here on the bottom graphs, we have 3 graphs, and always the horizontal axis is time since the origin of the earthquake.
Sorry, one second. When you say triggered, do you mean STA-LTA?
Yeah, this is STA-LTA. Yeah.
Okay.
I also put the machine learning algorithm in there, but I still have some troubles, so I'm just using STA-LTA for this first run, and it works quite okay. And so on the horizontal axis, we always have time since the earthquake origin, so it's in seconds, so it's always from the earthquake origin to 1 minute to 60 seconds after the earthquake origin. And then we have on the first one, on the bottom left, we have number of detections. So you can see that the first station detected after some 5-7 seconds, then 3 stations pretty much detected within 10 seconds, 4th station at like 15 seconds, and so on and so on. And then those 2, the bottom middle one is estimation of magnitude in time. So in each second, I pretty much do the whole process again and again, and I estimate magnitude and I estimate location. So it's the magnitude as it develops in time, and then epicentral error as it develops in time. So the magnitude should converge to that gray line, the gray horizontal line, which is the true magnitude based on the Mexican network. And epicentral error, ideally, it should converge to 0, because that's
in this example, 20 seconds feels when it starts to get it right.
So yeah, in this example, yeah, pretty much 10 seconds, it starts to get the location right, the magnitude. Yeah, it overestimates the magnitude, which is primarily because there is some location error, so it's located a little bit further away from the stations, meaning that it overestimates the energy of the earthquake, and it overestimates the magnitude, and then it goes down. So yeah, overall, like the first location we have in about 8 seconds in this case, but it's primarily driven by the number of stations that detected the earthquake in the first 8 seconds, 10 seconds. So yeah, these are a few earthquakes in here. It's somewhat limited. Like we would definitely need, and we will have in Puerto Rico, we will have more stations. Right now, like this is definitely with 20 stations in such a large area, this is as good as you can make it, because the earthquakes are mostly along the coast. Yeah. So you cannot really place stations. If you have 20 or 30 stations, you cannot really place them inland. But yeah, they are quite far apart. So we don't have that many detections of a single earthquake. Ideally, we would have many more detections from the network. But
so if we had say 90 stations like we're planning to in Puerto Rico, you would see much more rapid sort of determinations here.
Yes, yeah, it should be both more precise and more rapid. So in here, in this earthquake, we still have like, yeah, in 7-8 seconds, we already have some kind of like first, like on the magnitude, we already have some kind of first estimation and the first estimation of location that gets more precise. Sometimes it still detects some S waves, the secondary waves, instead of primary waves, which is a problem. And then it causes some misfit in or error in the location. And this is the magnitude 7.4, the largest earthquake that we recorded on that network. And that one has, you can see that there is a drop in the epicentral error, which is quite good, but then it actually got detected only at four stations, and the fourth station actually causes some kind of increase of the location error. However, it's not too critical. Like here, we would have 20 kilometers misfit of the epicenter, which for such a large earthquake is not that much, and the magnitude estimation is actually quite good in this case. So it's not. I'm still hoping to get better at this. It's still, I need to tune the algorithm quite a bit, but as a first version, I think it works quite all right for the purpose. It's not like preciseness for seismology as we would like it if we were doing some seismological kind of analysis, but for earthquake early warning, these precisions, if we reach these precisions or slightly better, it would be sufficient. So
so the deviations that you've had from the catalog magnitudes, like if you look at all the ones that you've studied, are they significant? Do you have any significant deviations in any examples?
I've done about 17 earthquakes, I think. There is nothing too bad. I think the worst one, like both higher and lower, like there was one earthquake where we had, I think, plus or minus 1. But this is primarily because of the location error, which I hope to get a little bit better at. So if you have a mesh location, the location has a big impact on the estimated magnitude. So, but it wasn't too critical actually. I think in most of them we are getting quite close. Of course, we can estimate magnitude reliably to about magnitude 7.5, and if it was larger than that, then the physics of the earthquake generation actually does not allow us in first, I don't know, 10-20 seconds to estimate an earthquake that is larger than that, because
but the message is the same for 7.5 and upwards. It's, get the hell out of there.
Yes, yeah, absolutely. And I think that's kind of what we are shooting for. We I really would like to get to since the earthquake origin to detection estimation, like reliable estimation of magnitude and epicentral position. I would like to get there in 10 seconds. I think that's kind of ambitious, but it's still like realistic aim, and I think we should shoot for that. And yeah, within 10 seconds we can estimate magnitude 7.5, and then just send the message out to get out of the house, because I don't think that we should wait any longer after that. So yeah, this is what I've been working on.
It's very exciting. I can't believe how similar they are in locations. I'm actually quite gobsmacked, because I know a year ago we tried this here with Luis, and we were always way out, and we just thought that it was because of the NTP time discrepancy, and we were never going to get there if we didn't have GPS. So, but obviously we're doing something wrong.
Time is not an issue, because this is, if we have mislocation of 10 kilometers, that's about 2 seconds. So if we have time that is more precise than 1 second, like that's not influencing the location error too much. Like that's not the crux. The geometry of the network is the crux, and yeah, and the number of stations, of course, too. Okay, so more stations and a little bit more in like a 2D grid, it will make it more precise, both magnitude and location. But But the time is not like we don't need to have more. We don't need to have GPS time for this kind of precision.
Well, I mentioned, so in Puerto Rico we have 90, and I mentioned that someone had come up with another 500 sites for us, which just requires additional funding. But yeah, so if that system scales with sensor density, then in terms of performance, then we'll be doing very well.
The only thing is in Puerto Rico is that, like, if the earthquakes occur inside of the network, it's going to be great. Like, the precision is going to be great. If it happens somewhere outside of the network, it's going to be, of course, lower the precision. Like, if it happens, I don't know, like, how large Puerto Rico is, but probably several hundred kilometers, right? Something like that. So if it happens 1,000 kilometers away, yeah, it's going to be, the precision is going to be lower. Like, every time an earthquake occurs outside of the network, it's problematic.
Also, Puerto Rico earthquakes. I mean, earthquakes there are not. They're not crazy big. I mean, you get some sort of 7s and etc. But if they're too far away, then they're no longer really a threat, are they? I mean, we only really care about the ones that are quite local.
Yeah, that's true. Yeah, that's true. I mean, like, we do care about those earthquakes that start somewhere and then the rupture propagates and it would propagate underneath Puerto Rico. So potentially, but I actually haven't studied seismicity over there, so I don't know if this is the case over there. So yeah, whatever. But 90 stations will take us pretty far in terms of this, and yeah, 500 additional sites, that would be awesome. Of course. Yeah.
I'm just aware of time right now. I also want to say, Vaclav, I don't know if I could ask you if you're available after this call, but I have a call with New Zealand. I don't know if you could join me. It's about OpenEEW there.
Yeah, for sure. Yeah.
Okay, I'll send you a link. Is there anything else anyone wants to mention today?
Not for me, no.
No, I'm just going to mention, I can't wait till we have I don't know, like the 4th version of the dashboard. We include all those graphics in like a detections page or something on the dashboard.
Yeah, I'm excited. I think it's going to be pretty amazing.
Oh, yeah. I guess since you guys are all here, I was going to ask if I can get some admin access to the detection repo so that I can set up a CI pipeline similar to the dashboard. So, when people merge in, it'll deploy to a cluster and things like that.
Sure. We previously, just so you're aware, we had done this whole thing ad hoc. Like, the few of us who were already admins had sort of just been granting them very, very freely. So I'm sure that's not an issue, but we do need to do little votes now in our sort of technical committee channel just for that, which I'm sure won't take very long. So we'll do that and get back to you, Adrian.
All right, thanks.
Okay, well, I've got to jump off, so there's nothing else.
Thanks, everyone.
Yeah, thank you, everyone.
Thank you.